So I'm Simon Thompson, Professor of Health Informatics at Swansea University. Lots of job titles, but it doesn't really matter. They're all much of muchness. What I talk about today is I just give I'm not going to go into detail about SaIL because I think everyone knows what SaIL Databank is, but obviously it's run out of Swansea University. It's part of a portfolio of infrastructure that we run, and obviously contains many, many billions of rows of data. I guess the more interesting thing here is that SaIL is a national infrastructure, but it's got health and non-health, and sometimes that gets lost a little bit. It's not just all about the NHS data, it's also about justice and census and HMRC data and environment and climate and all of those things. It's all still focused on people, of course. We have 85% coverage of GPs and primary care, as well as lots of the data sets that represent the Welsh population. We keep the data very safe. Accreditation is a big thing. So we have ISO, and we also have UK Stats Authority for Whitehall data, Cyber Essentials. All of those things is an ongoing task of maintaining appropriate permissions. I guess the other one is like, yeah, that's nice. So what? Well, I think SaIL operates. It's only 35% funded by Welsh Government. The rest of it is self-sustaining and has been for many years. And I guess it shows that actually an infrastructure of this size can effectively pay its own way, for want of a better word. Has produced 131 jobs in Wales, but it's actually supporting. This is the report for the last 5 years. Sorry, to be clear, it's supporting 189 million pounds of research. That's not money coming to Swansea. That's kind of in collaboration with a much wider set of people. There's about 20. SaIL itself has made about 24 million in the last 5 years. But obviously it supports a much bigger ecosystem than that, and obviously lots of publications, lots of public engagement. You can see in the annual report a lot of that. We are awaiting the official SDE status with our English colleagues. So SDE is an English-only concept at this moment. We have been accepted by Welsh Government with SDE for Wales. We're first in the queue for that accreditation process as and when it happens. But we're already holding 5 different ISO accreditations and Digital Economies Act accreditation and etc. So what's another one in many ways? And we are already received HDRS money to kind of push the boundaries of what's possible and help define what the HDRS program will be or what it might look like. But Wales also has this thing called SeRP, which I guess is a symbiotic, but actually mutualism. We kind of like the two work together to kind of feed off each other in many ways. And SeRP is the TRE provider underneath SaIL and many others. So this is a list of some of the people who use SeRP, run out of Swansea University. Our definition of a trusted research environment is, one TRE is many users using many projects, using many data sets. Other people have different opinions. Some people, a TRE for them is one project, one data set, and a few people, and that's absolutely fine. But that's not our definition. We're also running big trusted research environments in Canada and Australia, but today we're focused on the UK. So some of the TREs that we run are very mature, like SaIL Databank's been around 15 years, DPUK has been around 10 years. Emma registered about 8 years or so, and so forth. These bigger trusted research environments have actually started running trusted research environments inside themselves in many ways, which sounds a bit bizarre, but actually by running a trusted research environment inside another one, you're inheriting all of the process, policy, information governance, all of the things that perhaps are tricky to set up if you're not familiar with this domain. So for instance, traumatic brain injury, TBI reporter as it's called, it got funded. On day 2 of its funding, it went live. Why? Because it was inside Dementia Platform UK, and effectively there was nothing to do other than turn it on, for want of a better word, because there's already established government information governance and security and process and payments and so on and so forth going forwards. So this is a big growth market. So we're running 28 different trusted research environments across the UK, for which SaIL, DPUK, and MS Register are one of those. But there are now 12 of these trusted research environments inside trusted research environments. And there are 3 collaborative spaces, as we call them, which is research projects using it on their own data for their own purposes as part of a collaboration with working with a trusted research environment. The number of users we support is quite high. At the moment, this is a slightly out of date slide, but we're supporting 1,621 active users across the entire system in the UK only. There's another 400 in Canada and another 200 in Australia. But all the trusted research environments that we have are not born equal. There are differences. So we range all the way from the big ones, which we just mentioned, SaIL, DPUK, and MS Register, and UK LLC. And then there are smaller ones as you go down, which is basically perhaps more thematically focused or more specialist in some way. It's worth calling out the multimodality of the trusted research environment. So, imaging and genomics and cohort and health and non-health, these are all just assets that need to be mixed together and come together. We are talking to Singapore and Malaysia and South Korea about also taking over their provision. We will be taking over, not taking over, wrong word, where we will be providing a trusted research environment to Ireland. We already run the Northern Ireland trusted research environment, but we're going to be doing it in the islands of Ireland. So there's so many things going on that actually I just want to show that innovation is really key in this presentation. I'm going to talk about the more routine stuff. So it is really about patients. So we've been working with All Wales Medical Genomics Service for 8 years now on how do we kind of make safe access to genomic data. The initial batch of 300 have come through as a flush in the pipes, and it's all been agreed that yes, the data will flow to SaIL, and we will make the Welsh genomic data available as part of the entire collection, which is really fantastic. It's taken a long time to get here, but you know what, we got there in the end. But it's also worth pointing out, SaIL is perhaps a flagship, of course, but we need to learn from all the other trusted research environments that we do run. So DPUK, for instance, already has lots of genomic data, has 3 petabytes of genomics data. DataMind is adding 5 petabyte of genomic data across the UK. These are UK level things. And what we try in SeRP to do is that if one of the tenancy is really learning how to do something really well, how do you take the learning from that tenancy and make sure that all the other tenancies effectively benefit from that learning of the capability, so that we kind of create much more of a community rather than just siloing everything. Teams is rubbish, isn't it? Imaging is, again, 5 years to get here. I mean, you need a lot of patience, don't you, in this space? But we have agreement with one of the health boards of Wales to do a US funded AI model development. Imaging is probably the richest untapped asset in Wales today, and actually, if we can leverage all of the imaging across Wales, it's a game changer, I think, because especially in AI is very mature in imaging. The power of research in imaging is very, very mature, and I think Wales for once actually has to start playing catch up, whereas I think we've led the way in a lot of other modalities. But as an example of what's possible, Dementia Platform UK, one of our more mature, has taken neuroimaging as a specific part of imaging. It is now the central place for all neural imaging across the whole of the UK, and they've built quite sophisticated pipelines, integrating with Biobank and so on and so forth for their pipelines. But they do quite advanced things, like they take the 3D head scanner, CT scan of the head, and they take the face off, so it's not identifiable, but still keep it research ready and research utility. And there's a whole hour's presentation about the kind of cool things they do there. But I think it shows the art of the possible, that actually, if we can get a large collection of data with a set of science use cases, it absolutely is possible to do this safely and securely and for public benefit. Only 2 years. We did a proof of concept with Halvar a long time ago about NLP, natural language processing, for clinical trial recruitment. Very, very successful, but we haven't subsequently got funding to kind of take that to the next level, if you like. But we are working with Welsh Government about how SaIL could support clinical trial recruitment into clinical trials. And we're working with a number of vendors across Wales to kind of understand how an operating model might look like and how it might be done, both legally, ethically, and securely. We're hoping to come up with something recommendations by June next year about how Wales might choose to take this approach. Natural language processing has been another long burner. I think, again, it's another untapped things. 80% of all the data in the NHS is in free text. So we're missing quite a lot of the gold, if you like, of the data. There's been various pilots with DHCW, and some data has now started to flow to kind of do NLP. Again, strong relationship with Swansea Bay Trust in around epilepsy, that's now done much more routinely, and as a thematic theme, that's quite mature, but I'm hoping that can show the art of the possible, that it can be done safely and securely. King's are specialised in natural language processing. They're moving the national mental health pipeline for the UK into SaIL beginning of next year. So SaIL will, SaIL and SeRP will offer mental health natural language processing across the whole of the UK and hopefully Europe later next year. Cancers, a big area of growth. So SeRP UK has made a big investment in a program called CD3. SaIL is the official TRE underpinning a lot of that, and we're going to hold a lot of English data as well. But we're very, very interested in how we can add multimodality data to kind of really position lots of initiatives that happen in Wales to kind of capitalise on this big investment, so that Wales can kind of add up the sum of the parts and get much higher than one, and kind of show the art of the possible of a community like Wales that could achieve quite a substantial shift in cancer research across the UK. This is a complicated diagram. I kind of put it on because it just represents how complicated life sometimes is. We're supporting national initiatives such as the HDR UK Safe Research Registry, which is the thing in the middle. But we're showing how we're changing the trusted research environments to kind of plug into that, to kind of take part in national level initiatives such as this. And although I haven't spoken about it yet, on the right-hand side, we're also involved in quite a lot of federated analysis, and the federated analysis platforms are also going to plug into this. So a lot of the work we do is about integrating both systems perhaps we build, but also others build, and kind of create an ecosystem. One of the TREs in Canada is really interesting. The population is bigger than Wales. It's bigger than SaIL. It's very, very complicated. But it's got specific requirements where it's got health, but it's also taken over what they call DIP, which is the equivalent of ADR, which is the non-health, which is the justice and education data and so on and so forth for the whole of Canada. It has very different laws in Canada, so we're kind of having to create TREs where the same data sets are available in very, very different legal contexts in effectively 3 different TREs. Because the third one is also the indigenous nation, or the First Nation nation of Canada. There's very different laws about how, when you deal with this population, how the data must be dealt with. So again, this is how do you do this on the cloud when everything's so expensive, but you kind of need to create, you don't want to create 3 copies of everything, but you need 3 logical versions of the same truth, if you like, depending on the law and the governance that are applicable at any given moment. So that's quite interesting, both evolution of technology, but also evolution of information governance and command and control in many ways. We are converting the whole of SaIL beginning of next year to OMOP as a common data model, to integrate with a national initiative to kind of get to a common data model. We have done this in the past, but we've done it in piecemeal. We're doing it systematically now, starting again and doing it in a way that we can maintain that mapping as a core asset going forwards. There are many common data models. However, OMOP is the most dominant one across the UK, Europe, and the world. So we will be doing that. And again, we're doing it in collaboration with other partners, bringing the best of tools in from across the UK to kind of enable that to happen. Cool linkage. Everyone knows a bit of linkage. So it's deterministic and probabilistic linkage. Again, we've been doing this for years and years and years, but we're doing it as an area of science now, as opposed to just using, say, people's products to do linkage. We've worked with the HDW for years on how to do this, but we've been bringing lots of really clever people to kind of redefine what linkage means, and building tools and technologies, and again deploying to SeRP and deploying to DHCW to kind of enable that national capability of doing linkage. So we are doing deterministic, probabilistic at the individual level, but we're also linking at the residence, and we've gone all the way down to individual flats inside high-rise blocks, and the relationship between people and their environment is a very big part of what we do. But we're also linking with NHS England or NHS Digital for the augmentation of lots of cohort data under UKLLC for primary care, secondary care, and so on and so forth. So that's a really exciting initiative that, again, we're looking to capitalise on and expand to a wider set of use cases. We'll skip the last one. Synthetic data is really part of this new world because federation's coming, training's coming, everything's getting more complicated. The need for synthetic data was always there, but now the business driver for synthetic data is very clear. We have created open source tools, or DPUK has created open source tools to understand how you take a data set, create synthetic data, but more importantly, then judge its disclosive risk, its utility, and something else that I forget right now. But it's kind of how do you, because there's no such thing as a synthetic version of a data set. You need to understand what are your balance between utility and security and privacy and so on and so forth. So it's like we are already creating multiple synthetic versions of a data set to fulfill the different needs of the use of that synthetic data. And a lot of the work that the guys and girls have done is about how do you get that feedback loop and how do you prove in a sort of more in a metrics way how disclosive this is, or how much utility, or how much it's been changed, so that we can kind of conform against information governance models, which are very robust and need to be fulfilled, of course. We are looking to create a complete sandbox version of SaIL, DPUK, and the LLC by the middle of next year. This would effectively create a training test environment of all of this. So again, this is kind of upskilling. There's a lot of drive to upskill the community so that they can kind of get more utility and do better science and faster science. We're also part of Elixir UK and Europe. We're one of the newer members. This is really important because this is a whole community that brings bioinformatics and genomics in a way that perhaps we haven't understood the scale of this sort of investment before. We're already making a big impact on that because a lot of them don't particularly handle sensitive data, whereas sensitive data is our bread and butter. But they've got the tooling, the expertise, and we've got some great partnerships already underway because of this new collaboration. And I think I'm running out of time, so I'll go a bit faster. The federated analysis is the new big thing that we're building. So federated analysis for trusted research environments. So we're part of Dare to Evolution. We're the lead architect for that. We're also part of HDR UK Pillar 1 Federation, and announced this morning, we're now part of UKRI FedS, which you can Google that, and it's not Asterix anymore. It's now been announced, which is Swansea leading a £3.7 million proof of concept for federation of imaging data, for instance. We produced a massive report on what federation means, but we know that federation falls into many categories. One is about moving data, one is about federated analysis, and one's about federated learning or AI and machine learning. And we did a proof of concept of lots of this technology that we've got some products in this space that have been deployed, and Dementia Platform UK, for instance, and SaIL have deployed these in the real world and are actually using these and kicking the tires of them, which is fantastic. We have an ability to kind of pop up a trusted research environment and interconnect lots of TREs together, so that the user experience of this is that the researcher has a single pane of glass across multiple trusted research environments, and can kind of see all of the data and combine it together and do the science that they need to do. But the entire environment is wrapped by all of the trusted research environments, information governance models, and security and control and all this good stuff. So kind of a bit like a Russian doll, so that everyone's kind of still got that control over the use of their data. The alternative model we've got is the eyes-off model, where you send the analysis to the trusted research environments. It gets executed, the answers get egressed, and the answers get combined together going forwards. So this product is called Trifix. This is a very different model. So again, we've aligned to international standards. So Global Alliance for Global Health, TES, is an international genomic-focused standard, but we've repurposed it for both genomic imaging and EHR and cohort data to kind of make sure that we're not reinventing the wheel for no apparent reason. And what we've really done is we've taken the 5 safes of the safe people, safe projects, safe environment, safe data, and applied it to what is effectively quite an open framework to kind of make it much more aligned to information governance and the way that trusted research environments have to operate. And the last one is federated learning. Nothing wrong with federated learning. Everyone loves a bit of federated learning. But the problem with federated learning is the fact that you have to have an aggregator at the top, and the payload goes out to a trusted research environment, computes some metrics, brings them back, combines them, goes again, and maybe it comes back several thousand times. The real problem here is that normally where the green blob is, that's the equivalent of the border. That's where egress or information governance responsibility ends. But in this scenario, actually it's the orange blob on the right that has to do. So this breaks the model of trusted research environments' current information governance model. So we're bringing technology to kind of solve that in many ways, and I won't dwell on it too much today because this talk's really a whistle-stop tour of the kind of things we get up to rather than digging into any detail about any of these aspects. The next 12 months is going to be really cool, very radical. There's over now £10 million investment across the UK in federated and analytics. We, as a major provider, so we provide 1/3 of all the trusted research environments in the UK. We're obviously very keen to understand how this model changes over time and how we plug this in, how it plugs in safely so that we can kind of enable this new potential future in a very safe way. So I think there's going to be a lot of changes that we're going to embrace and co-develop across the UK in the next 12 months. That's my whistle-stop tour. Thank you.
Thank you. That was a real load to take on. And so I'm going to move over to Emma to give people a chance also to think about the bits they want to ask you more details on, because I'd like to ask them a bit more after about synthetic data and the uses that are allowed. And Emma is going to talk now about DPUK, which given us more insight into one of the partners within SeRP. So I'll hand over to Emma.
Lovely. Thank you, Sinead. I'll just share my screen. Okay, hopefully everybody can see my slides. And I'll I'm just going to give a introduction to Dementia Platform UK. We're one of the major tenancies of SeRP. We've been running about 10 years now, I think, from initial starts. I've been working with DPUK for about 5 of those years. And we've been really trying to push forward into a multimodal area to be able to advance our capabilities. Okay, so it's grown hugely over that period of time. We've now got about 107 data sets that we're bringing together across dementia research. So a lot of our studies are cohort data sets that have been collected for research that are being used for secondary onward sharing. And we bring those into our trusted research environment, and we allow researchers to be able to apply to access those data sets to do research into neurodegenerative disorders. We're fully MRC funded. We're going for our 3rd round of funding to keep us going. Because we are fully MRC funded, we are free at the point of use. So all the data inside DPUK, if you've got a good study that you want to undertake, you can apply to access that data. And if the data providers feel that your project is sound and in the public interest, then you will be able to access those data sets to carry out your studies free of charge. Any big extras like HPC cluster compute or large storage would be cost recovered, but for a standard project, they are free of charge. We've processed over 16 project applications during that time, so it's quite a mature TRE. We accept applications globally as well, so over 40 countries we've received applications from, so a very broad global user community. So just for anybody who's not 100% sure what a trusted research environment is, and they do vary from organisation to organisation, this is just a quick overview. The data is kept in secure servers and we use SeRP infrastructure, and the data comes in. The identifiable data is stripped out of that data that's coming in, and we store it on the secure servers inside the environment. As I said, researchers can then apply, and if they're approved, they're provided with a virtual desktop that has all the software and the environment that they need to be able to analyse that data. However, it's a lockdown environment. They can't access the internet. They can only carry out their analysis, and once they've carried out the analysis, they can apply to have any results removed from the environment, and we would take a review of those results before we let them out to make sure that the data wasn't on. So these are really for sensitive data sets, not for public or data sets that are out there, for data sets that couldn't be accessed unless they were in a trusted research environment. We follow the 5 safes, so we have safe people, we check vet researchers coming in to make sure that they are bona fide researchers. We have safe projects. Every project is reviewed to check that they're scientifically sound, they have analysis plans, they're in the public interest. We've got safe settings, we've got to use SeRP infrastructure, we're fully ISO 27001 accredited, both on the SeRP infrastructure and also for our data management processes. So we're very auditable, and we abide by all the rules that we can. The data, we only provide the data that's required for that project. So research would only ever access functionally anonymised data. And like I said before, we review all file outs to make sure that there's no low counts or anything that could potentially be disclosive in the real world. For the period that I've been working with DPUK, there's been a real drive on bringing in multimodal data. So not only the survey data or the clinical data for research participants taking part in research, we're also collecting imaging scans, like Simon mentioned previously. We've got a lot of genomics data. So we're really starting to build up a big picture, a big deep dive on these participants. So we have a lot of information about the same people. So it makes it a very rich repository of data sets. We also focus heavily on discovery tools. Being able to find the data that's required is really important, and we're looking at multiple ways of how we can improve those discovery tools. And as we've brought in the neuroimaging data and the genomic data, we've been pushing to have bigger compute. We need bigger compute, we need bigger storage. So we've invested in data lakes, we've have HPC cluster, and these have all been provided by SeRP for us to be able to use. And as SeRP develops these, we benefit from the use of them. So data discovery is a big one for us. We've got our matrix level tool, which shows everybody the data sets we've got and a nice snapshot of the type of variables that are collected. We go down into a data dictionary where we show the variables that are in those data sets, and we can even go down to an explorer level. We've got 40 variables harmonized for 15 of our data sets, but that gives a real deep dive into those data sets. Neuroimaging data, as Simon mentioned, is really big for DPUK. We've brought in over 130,000 brain scans. I think that's up to about 180,000 now. So we keep adding to that repository. We're bringing in public and synthetic data sets to bring those in as well. So the offering that we have is growing and growing, and with it the demand to be able to access this multimodal data has grown, which has led us towards looking at things like synthetic data and AI and other things to be able to help us handle this type of data. Genomics data, again, we've got a lot of genomic data coming in, varying from basic VCF files to PLINK files to GWAS to whole genome sequencing. And these can be really large data sets. They're quite a challenge to handle and to be able to allow people to compute, because the minute they start computing them, they get much, much bigger. So the storage requirements are really high. We've had a nice project that's undertaken in DPUK that has generated a pipeline that takes the imputed data sets. They impute them and they've managed to generate polygenic risk scores. So these risk scores give us an indication of the risk level of the participants that are in DPUK. So this is a really nice example of work that has been taken and allowed us to enhance and augment the data sets that we currently have in place through all the technology that's been stood up for us by SeRP. We also do a lot on registers and trial support, and this is growing bigger and bigger. As soon as we are recruiting participants from studies, many are from memory clinics, we actually have the ability to ask these people to join registers to be recontacted for clinical studies and clinical trials. So this has grown up over time. I know we've got over 65,000 volunteers in our Great Minds register alone. We've also links to joint dementia research, and with these proposals going in to be able to expand that further and bring all these registers together to enable really large scale recruitment to clinical trials. So this is a really exciting area of work that I'm sure will progress over time. We're also one of the first adopters of the federated solutions that have been developed, particularly through the DARE programme. We won TREFX, which is one of the solutions that Simon put up, between ourselves and Alzheimer's Data Initiative, which is a global consortium that's bringing together dementia data from across the world and allowing federated access through it. So this is a really exciting thing to be part of, and really allows data to be accessed from all over the world, and allows us to partake safely by using the SeRP technology. We also have a pop-up TRE between ourselves and the SAIL Data Bank to allow researchers to be able to access population data on Welsh participants in combination with the cohort participant data inside DPUK. As Simon said previously, we've worked really hard on synthetic data. It's been really important for us to address areas such as student training and researcher training, to be able to allow data discovery. If we can surface the synthetic data, people can actually see the real structure of the data, not just the variable names and some vague bits about values, but they can actually really get a good idea of what that data is. For federation, like I said previously, being able to develop an algorithm while seeing the data, particularly with the eyes off, is really important for us as well. So a lot of work has gone into being able to develop synthetic data, assess how synthetic it is, and then working on the governance model about how we can use this. So my colleague Lewis Hotchkiss has worked really hard on this. We've had a lot of funding to be able to do some workshops that have looked at the public and researchers, data providers, to bring together their perspectives on synthetic data and start generating these models. Lewis also led on the development of a SynthOpt tool that can generate low, medium and high fidelity, but also give reports about the distribution of variables and all sorts of clever things, so you can get a really good idea about how synthetic that data is. We've also done a lot of work around artificial intelligence governance as well. Since we've brought in the neuroimaging data and the genomics data, a lot of researchers have approached because they want to generate AI models, particularly for dementia, predictive AI models, or being able to identify people really early. This poses a huge challenge to us because we needed to make sure that those models didn't inherently contain the data when they were taken out of the environment. A lot of work went into generating work, again, led by Lewis, and we have generated a whole framework about how we assess and allow AI model development inside our trusted research environments, and ways we can host those models to make sure that they're safe. We're also looking at a lot of large language models and how we can use these for data discovery. It'd be so much easier if we can put in how many people have dementia who are female and a medical history of depression, and then the computer tells you there's this many people in these data sets. That'd be a wonderful thing to do rather than having to trail through and find all the variables that you need. And we are putting a lot of effort into that, and hopefully through new initiatives we'll be able to scale that up as well. And that was me done. I've just got a little slide for all the people involved across Oxford and Swansea that really helped to push DPUK forward and make sure it's a good repository for research. That's it from me.
Thank you. Thanks very, very much, both of you. Does anybody have any questions they'd like to ask Simon and Emma at the minute? Any thoughts? In terms of getting the AI models, oh, sorry, go ahead. Go ahead, Senator.
Thank you, Simon, for that presentation. I wanted to ask, trying to aggregate the OMOP model to the data we've got in the UK. In some cases, there are discrepancies with regard to the data set, because I think the OMOP is US based. And for example, if you're looking at ethnicity or race, in the US, they always say like Latino or non-Latino, but in the UK, that's different. We've got white, British, African. So how can we correlate that if we're actually adopting the OMOP model?
Yeah, absolutely. So there are some of those peculiarities that come from the original creation, if you like. But I think with wider adoption of OMOP, some of these things are now being surfaced and addressed, because actually that's not acceptable. It might be acceptable to the American population, but it's not acceptable to us. So the other thing that we're doing is, why are we redoing it? We've done it before. And that's because when we did it before, we had all of these issues that you allude to, right? We're now part of a bigger consortium where we're all agreeing the way that we should map it, because the other consideration is, if we all map it differently, we haven't got a common data model, we've got a common structure, we haven't really got the same thing, right? So we're also adopting as many open source tools as possible, and we are looking to get our mappings and share them as an output, because PEDU in Wales and SMR in Scotland are functionally identical. We only need to map one of them, and the other side can benefit. But we've also learned you need to maintain these mappings. So we need to be part of a community that maintains these mappings. And as these anomalies get detected, because it's never going to be perfect, actually, as a community, we can then go, oh, we need to do something about this, right? Everybody, let's do this. And then everybody does the same thing. And hopefully these things won't happen in the future, or if they do happen, we can resolve them in a very collegiate way.
Thank you.
Thank you. Any other questions for Emma and Simon? So, Rita, please go ahead.
Hi. This thing about genomic data, Emma mentioned the VCF files. So I assume that these are just for the dementia, people with dementia. But Simon, you mentioned genomic. So what is it? I mean, I know what genomic is. Sorry, what sort of data you've got?
Yeah. So the initial payload coming in to SaIL, that particular one, is 300 VCF files. The agreement in principle is that all VCF files from all historical and all future VCF files will flow systematically into SaIL, while we talk about how we protect the identification risk of the more less processed data, such as the BAM files and FAM and so on and so forth. There's a bit of convincing to do, if you like, inside the NHS. So SaIL also runs a trusted research environment inside NHS Wales. It's very likely that data will live there, get processed, and come over to the SaIL side. But this is work ongoing for the more detailed data. But today, I would settle for all the VCF files that ever been produced in Wales. That would be a start, because it's taken 5 years to get this far.
So I was just thinking about the Always Medical Genomic Services, when they just do the genetic tests for various diseases. So you don't necessarily have the VCF files, you just have test results, or for epilepsy.
No, the plan is to get the VCF files from all Wales Medical Genomic tested people systematically.
Okay. No, my question was whether you get, for example, things like epilepsy results, which are not VCF files. They will be just test results, or tests for specific genes. So it's like test results, not the full VCF files.
Yeah, absolutely. So we need a feed of the genomics limbs to do that. And the genomics limbs, for those who know HSPS, is an ongoing process of a transition from an older system to a newer system. So it has been agreed that when All Wales Genomics Service has settled on their new system and they've got it all migrated across and they're all happy, we will take that as the feed also, which which I believe the data that you're particularly interested in will be in that.
Okay, thanks. Thank you.
Thank you. John, you were saying about asking a bit more about the synthetic data, and I think the link put there, is that for the open source tool that's been uploaded by Ian Farr, or is that a different link?
That's a different link, but
Link. Yeah, so
but sorry, Lewis has just posted the
brilliant.
link.
Super.
Right.
Thank you, thank you. So I totally agree that an OMOP community is very, very much needed. Otherwise, like you say, we all map different things in different ways and they're not comparable. So how do you invite other people to be part of that, or how do people who are OMOPing get to be part of that?
Yeah, so the beautiful thing about the UK is there are 3 groups doing the same thing, having a nice time. So, you know, there's one led by Nottingham, one led by HDR UK, and one led by Oxford. And I guess someone needs to bang their heads together and get the groups to come together. That would be good. SaIL is he's joining in with the Nottingham initiative, which Scotland is also joining in, as is Biobank, as is Future Health. So, you know, that's okay, but what we're trying to work on is the same tools for doing the mapping, same tools for actually doing the transformation. But then there's folk thinking about how do you share those mappings as an asset, right? And if you shared them, how do you describe them? And how do you pull them back down? And how do you utilize them? And how do you create that learning loop, right? It's never been done before that we can say, I mean, people have shared their mappings, of course, but I mean, at scale, systematically, because in many ways, what we really need to do is to work almost like source control. If we agree that Scotland is doing its equivalent of PEDU to the same level of robustness as us, actually, we need to share that code. And if they make a change, it should apply to us and vice versa. And that's how we need to try. That's the end game, if you like. I think we're a way off that, if I'm being honest.
Is there somewhere to share it? Are you saying put it on the GitHub, or
Well, no. So so Biobank has all its on GitHub. We have ours on another sharing platform. Nottingham doesn't share them. Scotland's got them if you ask them. So, you know, there isn't a platform where one would put them yet, right? But there's a proposal for maybe an extension to HDR UK Gateway to do this, and or we build an open source repository for this sort of thing. It's not enough to just put it into Git, because that does make it shareable, of course, but the computers need to be able to read it and the metadata around it. So it needs to be stored in a structured manner. We're already doing this with Workflow Hub for workflows, for instance. So this is the equivalent of Workflow Hub, but for genomic mappings, for want of a better word, right?
Does anybody have any other questions? Otherwise, I'd like to know a wee bit more about the synthetic data. Do you see this being at the level that students could just use it without needing a lot of controls, in which case you could use it for teaching? Or do you think it's actually going to need to be regulated? And could it be used if you want to get out your AI models or your prediction models? Could you then place them sort of on the synthetic data? You can train them and make them on the real data, but then place them on synthetic data and then get them out. Do you think?
Yeah, I think all that's possible. But I think a lot of it's got to be worked out. So I think there is synthetic data for all the use cases you talked about, but the guys are also looking at synthetic data to undo bias in AI training, and I think that's a different angle, but that's equally as important, right? I think both SaIL and DPUK are both going through a process of understanding the governance arrangements for the release or a more accessible access to these new derived data sets. As Emma alluded to, that feedback loop is really key, because we can make high, medium, low fidelity versions of these data sets, and it's very likely that if we did that very simplistically, they would have different arrangements for it. But the idea is the lower fidelity data sets, the aspiration is to get to terms and conditions, not a full-blown legal contract to be able to access them. But we have to get permission from the data owners to do this, and we also have to ensure that the legal framework by which we're doing this is okay. So that just takes a bit of time. But SaIL recently ran a hackathon with synthetic data. That's the first time it's ever done it. DPUK is a bit ahead of SaIL in that. And DPUK has been talking about to its data providers about their risk appetite for what level of synthetic data, whereas I think SaIL's got a different problem because it doesn't really have that. It has delegated authority for most of its data, so it's going to have to make platform level decisions on behalf of a community. So I think there'll be a delay, but I'm hoping by mid next year there's something really tangible. And I think what I mean about setting up a sandbox TRE is if we had another TRE with a different governance model, a lower governance model, a more accessible platform, this opens opportunities for teaching and so on and so forth, right? For students and so on and so forth. A lot of institutions are also looking for early access to data, as in get access to synthetic data, start your science while you wait for the application to be signed off and then switch to real data. The problem is that Wales is down to whatever 4-week delay. Other people are a year and a half. You know, NHS England is a 15-month delay to get data, in which case that's a no-brainer. Let's get going with your science and get the real data. We don't have that problem, so we're not driven by that requirement, if you like. Neither, and DPUK's turnaround 3 weeks. You know, it's like there's no delay here as such. So I think training and skill development, and when we do federation is going to be really tricky because it's brand new. Everyone's going to be risk averse. Federation has to happen on synthetic data first while we flush the pipes and show the art of the possible and socialize everybody to the idea of it. So training and synthetic data and federation are the business case, why we're investing so much money in synthetic versions of data sets, because they're very hard to compute and they're very hard to develop, and you have to have very clever people to kind of build the algorithms to do it. It also changes a lot on the modality of the data and the scale of the data and the shape and nature of the data. So there isn't really a silver bullet to this.
I mean, doing the synthetic version of the OMOP data would mean then you can make sure that you've mapped things to do the federation properly. It would simplify the analysis. So actually all these things coming together would rapidly change what we could do. Emma, there's been quite a bit on the imaging in DPUK, yeah? What are the next steps in order to get people more up to being able to use the imaging data? Because that really is the most exciting area to go into now.
Yeah, okay. So there's kind of for next year, I believe there's a neuroimaging academy to be able to start skilling people up to use raw imaging. But a lot of the time, particularly in DPUK, people come to get the neuroimaging data and ask us if we'll have the image-derived phenotypes. So have we got the brain volume and the usual measures that they would just be computing themselves with the raw imaging data. So we've put a lot of work into generating pipelines to generate the most common IDPs that are requested, and that kind of reduces the skill level required to use the raw imaging data and allows people to take those IDPs and combine them with the genomic and the cohort data to get a nice understanding of what they think, so they can bring it into their research without having to use as much resource as they need. And we've also even taken it just to the point where the imaging data has been pre-processed and is now ready to run. So depending on what people need, they need to do it from the beginning, then we can offer raw imaging, but they're going to need to have a lot of compute, they're going to need to have a lot of storage, so it can be quite expensive. If we do the beginning steps, then it reduces the amount of skill, and it also reduces the amount of cost as well. So that's the plan from our side.
Brilliant, thank you. Does anybody have any final questions before we let Simon and Emma go? Any last questions before? So thanks very, very much. I think it was fascinating, and we'll have to get you back again next year to give us an update of where things have gone to. So thanks so much. It was really, really, really fascinating.